Now in the next lecture I shall talk about hypothesis testing using predefined functions in R. So this is my next lecture. Well, now in my new topic I am going to talk about hypothesis testing using predefined functions. See, students t-test, the function t dash test is meant for, it is not dash, it is t dot test. It should have been t dot test. So here I have to make these changes. It should have been the function t dot test. T dot test I have written in backticks. So the function t dot test, and then we can generate the PDF after this modification. Just go into knit button and knit to PDF. Oh, I should have closed first. Before running, now I have to run this knit to PDF. Then only it will run. Oh. Knit to PDF document 2. Now there is some problem. Okay. We will talk about these things later. It is actually t dot test. It is t dot test, not t dash test. So see, here we have used t dot test. So the function t dot test is meant for testing single mean, two means, and paired observations also. So our commands are single sample test. For single sample test, we have simulated data set dot seed 2. We can have any number here, that hardly matters. So y is equal to R norm 20. So 20 observations are being simulated from normal distribution with mean is equal to 10, SD is equal to 3. And we want to test H naught mu is equal to 8. Here mean is 10 and we are testing mu is equal to 8. See what happens. Mu1, H1, mu is not equal to 8. The student t-test here, t dot test y, mu is equal to 8. See what happens. It is being rejected. It is being rejected. This is the hypothesized value of mu. Mu is equal to mu naught, one sample t-test. The value of t statistic is 3.64 and degree of freedom is 19, because degree of freedom is number of observations is 20. So 20 minus 1 is 19 and p value is 0.001733. So it is much less than 0.05. An alternative hypothesis, true mean is not equal to 8. 95% confidence interval. Here this interval does not contain A. It is 9.1 to 12 point. So that means this mu A does not lie in this interval, and so either we say p value less than 0.05 or we say that this calculated value is greater than the tabulated value. Calculated value is greater than the tabulated value, or p value is less than 0.05, or if hypothesized value does not contain in this interval, it is not contained in this interval. So that should also be concluded that the H naught is being rejected. So this is another interpretation. So mean of x is 10.58. See, if we look into the args of the arguments of the t dot test, see, go to help t dot test. See, t dot test is in stats package. Student t test description performs 1 and 2 sample t test on vector of observations. So here t dot test xy alternative, see, two-sided. The first, by default it is two-sided alternative. If we want less than mu is less than mu naught, then it is less. If mu is greater than mu naught, so it is greater. It depends upon the hypothesized value. Say for example, if we will use t dot test, say we are simulating the data R norm. So here y is this. So these are the 20 observations with mean 10, and if we want to test t dot test t dot test and the vector is y1, it is y, and mu is equal to 8. So this is the hypothesized value, mu is equal to 8. So it is being rejected. But if we have the hypothesis, because hypothesis could be mu is less than 8 and it can be greater than 8 also. But here mu is not equal to 8. So this is the alternative. If we want to test less, so here the argument is alternative is equal to, by default it is two-sided. Suppose we want to keep less, then what is the result? Again it is being rejected, and no, it is p value is 0.991. So that means it is not being rejected. And if we talk of greater GR EATER, greater GR E its p value is less than is not being rejected, but when it is greater 0.0086 it is being rejected. So this is the effect of alternative hypothesis. And similarly for t test for 2 sample, this was all about t test for 1 sample. Now t test for 2 sample means y1 random observations with, there are 10 random observations from normal population, mean is equal to 8, SD is equal to 2. Y2 12 random observations from normal distribution, mean is equal to 3, SD is equal to 1. Here SD is also different and mean is also different. Now we are using t dot test y1, y2, where dot equal is equal to true. var dot equal is equal to true means actually it because our h naught mu1 is equal to mu2 versus h1 mu1 is not equal to mu2. But what about sigma square? If we are assuming that sigma 1 square is equal to sigma square, sigma 1 square is equal to sigma square. So that means here the argument is var dot equal is equal to true. So this argument is satisfied by this assumption. So here it is known as var dot equal is equal to true. var dot equal is equal to true. And if it is not, then it will be a different, it will be Welch test. If this is not, then it will be Welch test. So actually here var dot equal is equal to true has been written, but actually it is giving var dot equal is equal to false, and that's why this result is coming. See, we can verify these results. See, what is the value of t statistic? The value of see here actually it is var dot equal is equal to false, and that's why we are getting Welch test for t test. Here data y1 y2, t is this, and degree of freedom is 10.43, p value is this. So alternative hypothesis is true difference mean in means is not equal to 0. So there is significant difference. 95% confidence interval, it does not contain 0, so that means our h naught is being rejected, because h naught mu1 is equal to, this is equivalent to h naught mu1 minus mu2 is equal to 0. So the alternative will be h1 will be mu1 is equal to mu2 is not equal to 0. So this will be the alternative. So that alternative is here, is not equal to the 0. And 95% confidence interval does not contain this 0. So that means our h naught is being rejected. Our h naught is being rejected. So, and these are the values of mean of x, and this is the mean of y. So actually if you look into, see, we will run then control 2 t dot test y1 comma y2. This is the Welch test, because here we have not given var dot equal is equal to false. So this is a kind of approximate test. Welch test is an approximate test. Actually, when variances are not equal, it is a very difficult problem to handle classically. So several approximations have been developed. One of the approximations is developed by Sukhatmi also, and this one is developed by Welch. So this is the Welch test here, because you know the degree of, this is an approximate t test, degree of freedom is 10.431, it is not. And when we want to var dot equal is equal to true, so in that situation this is the common t test we teach to our students. var dot equal is equal to var dot equal var dot equal. Here you see degree of freedom is 20. because it is the exact t-test. It is the exact t-test. And it is also giving the p-value which is much less than 0.05. And the conclusion is same, but here assumptions are different. In the t-test, when we write var.equal is equal to false, it gives Welch test and approximate t-test. Here degree of freedom is 10.43. And when we write this is equal to true or capital T only, it gives exact t-test. So this is the exact t-test. So this is the difference between exact t-test. Now see, we have already talked about the two sample t-test, but the function is same. For single sample we just give only one. We just give only one argument y1 and we don't give these things. Only one give, and here we specify mu is equal to 8 and we were testing h0 mu is equal to 8, and that was the single sample. But same function t.test here, if we are giving two arguments, var.equal is equal to true, it returns the Welch, it returns the exact t-test. When var.equal is equal to false, it returns exact t-test. Here it should have been var.equal is equal to false, and then only we will have this output. Now paired t-test. Paired t-test, observations in paired t-test must be paired. Observations in paired t-test must be paired. For example, blood pressure of the same person in the morning and in the evening. Another example, if we are comparing two groups of animals, so blood sample should be taken from the same animal in the morning as well as in the evening, then those observations are termed as paired observations. So they are in that situation, although we will have two samples, but they will be paired. So in that situation, we have to make use of paired is equal to true. Otherwise, if we will not give this additional argument paired is equal to true, it will, see what we do in practice, what we do. Say y1 and y2, these are the two paired observations from the first animal, second animal, third animal, like this. So what we do, we define differences. D is equal to y1 minus y2, and then we test mu d, the difference of these should be equal to 0 versus h1, mu d is not equal to 0. So this difference becomes the basis of inference in paired observations. So paired is equal to true, and the test statistic is d bar divided by s square root of n. D bar, s is the standard deviation of di's, SD of di's. So that has been done here, and degree of freedom is n minus 1. So here t value is, since each group is having how many observations? It is having 1, 2, 3, 4, 5, 6. Each group is having 6 observations. So degree of freedom is, the value of t statistic is this one. This is the value of t statistic, d bar divided by s by square root of this. So this is the value of t statistic, degree of freedom is 5 and p value is 0.01. So that means our h0 mu d on average difference is equal to 0 is being rejected here, because p value is less than 0.05 and this confidence interval does not contain 0. So that is another way. Alternative hypothesis is true mean difference is not equal to 0. So this is the interpretation. And sample mean difference is, this is d bar. This d bar is nothing but sample mean difference is minus 1.33. So we have talked about pair t-test. Now if we go here, pair t-test, so here and then pair t-test, this is the result, this is the output. So that means we are using the same t-test when our observation is y1 and mu is equal to say 8. This is the single sample t-test. When, so it is being rejected. When we are having two sample observations, y1 and y2, it is two sample Welch test, and this is nothing but var dot equal is equal to true. So this is var dot equal to true, degree of freedom is this. So this is not being rejected, this is being accepted. So it depends upon what data, because y1 is this one, y2 is this one. So here our t value is less than 2, minus 1.37, degree of freedom is 10, and p value is 0.20. So that means we are not rejecting, it is not less than 0.05, it is not less than 0.05. So that's why we are not rejecting the h naught mu1 is equal to mu2, and here this is the output. But the same test t-test, same t-test, y1 comma y2 comma paired, it implements paired t-test. Paired is equal to true, or simply you can write paired is equal to t. So here could not find the function t-test, it is t-test. So this is the result. So this way this t-test works in for all the purposes. It works for single sample, it works for two sample means, it works for pair t-test, it works for two sample when variances are not equal, and it works for when variances are equal. So this is all about t-test. Now we can talk about this chi-square test, but before chi-square test I would like to talk about var.test. var.test. See, var.test. var.test. Suppose we want to test h naught sigma 1 square is equal to sigma 2 square versus h1 sigma 1 square is not equal to sigma 2 square. So here for testing this, the test statistic is f ratio s1 square divided by s2 square, and it follows f distribution with n1 minus 1 into n2 minus 1. n2 minus 1. So these are degrees of freedom of f statistics, and this is nothing but var.test. This statistic is var.test. So we can make use of, because we have made this assumption sigma 1 square is equal to sigma 2 square. We have made this assumption about sigma 1 square is equal to sigma 2 square. So, to test this hypothesis before using t-test for 2 sample, we can use var.test. It is all with var. So, var.test is nothing but y1, y2, and this is the result. The calculated value of f stats is 1.61, degree of freedom is 5, and the degree of freedom for numerator is 5 because it is 6 minus 1 observations in the s square. This is nothing but s square. Actually, this is the value of f statistics is nothing but var of y1 divided by var of y2. So, this is 1.61. This is 1.61, which is the value of f statistic. And degree of freedom for numerator is 5 and degree of denominator is also 5 because the length of y1 is 6. So, it is 6 minus 1, 5 degrees of freedom, and p value is 0.611. So, that means what? We are not rejecting sigma 1 square is equal to sigma 2 square. Auto hypothesis true, ratio of variances is not equal to 1. See, either you say sigma 1 square is equal to sigma 2 square, or we can say sigma 1 square divided by sigma 2 square is equal to 1. So, he has alternative sigma 1 square is equal, sigma 1 square divided by sigma 2 square is equal to 1. And this confidence interval does not contains 1. So, that means our H naught is not being rejected, it is accepted. And this is the value of t statistic, and this is the value of p value. This is the value of p. This is the value of p. So, I have already concluded this F test. We can verify these results, see, by going, say for example, we can compute all the value of p etc., but we are not going to do that. So, this is all about now variance. Now, I'm going to the PDF. See here, actually what var.test implements, var.test implements y1, y2. It implements h naught sigma 1 square by sigma 2 square is equal to 1 versus h1 sigma 1 square divided by sigma 2 square is not equal to 1. So, instead of writing in this format, here the test is defined in this format. Sigma 1 square is divided by sigma 2 square, and here the ratio, for the observations we have used, this is being accepted, H naught is being accepted, which we get by using var.test. See here, var.test F ratio is 1.61, although it is much greater than 1, but it is not significantly different from 1 because p value is 0.61. So, and this confidence interval does not contain 1, so that is why we are rejecting H naught. We are not rejecting H naught. Sigma 1 square divided by sigma 2 square is equal to 1 is being accepted. So, this is all about the t-test and Now in my next video I shall talk about chi-square test, and that will be tomorrow inshallah, chi-square test. So that's all for today's. See, it is chi-square test, and then we shall talk about analysis of variations. So these things will be discussed tomorrow inshallah. These things will be discussed tomorrow.